Hello, so today we're going to be looking at how to make a standard solution. So this is the first video of a practical series of videos I'm going to put together, but this also overlaps with the amount of substance topic. So by the end of this session we should be able to explain the procedure for making a standard solution, and you should be able to suggest improvements to procedures already given for making up standard solutions and how to spot errors. We're going to look at some exam questions from all the different exam boards as well, but we're going to first of all focus on the actual practical technique about how to make a standard solution. So what is a standard solution? Very simply, a standard solution is a solution where we know the exact concentration, and it's made by knowing the exact mass of solid that we've added to an exact known volume of water. So let's have a look at the method. Okay, so first of all you need to gather your equipment. Most of the equipment is shown here, so you need a balance, you will need a beaker. The beaker size you use will depend on the size of standard solution, but probably about a 250 centimeter cubed beaker. You'll need a volumetric flask. Again, this does depend on the size of the standard solution you need to make, but probably a 250 centimeter cubed volumetric flask. In addition to this, you're also going to need some distilled water, you're going to need a spatula and a filter funnel. We've also got a weighing boat or a weighing bottle potentially, and that's to weigh the mass of solid on. So the first step you need to do is you need to tare the balance. So the balance must have nothing on it, must be clean, and you're going to press the tare button which will zero the balance. So this is going to zero the balance. Okay. Then you're going to record the mass of an empty weighing boat on a 2 decimal place balance, or more decimal places, the more the better, but you're going to ultimately you need to record the mass of an empty weighing bottle or weighing boat. Step 3, you're going to, using a spatula, you're going to add the solid to a weighing boat, and then you're going to put the weighing boat onto the balance, and you're going to record the mass of the weighing boat and the solid sample. Okay, so obviously you'll need to know roughly what mass of solid you're going to need, so that might involve a calculation to work out the mass, because obviously you'll want to know the concentration of this, but the key thing is you're going to weigh the boat and the solid sample. Okay. Step 3, you're going to add the solid sample to the beaker, and then you're going to reweigh the weighing boat. So this is a technique known as weight by difference, because ultimately we want to know the mass of solid here. So and in the previous example, the mass of the weighing boat on its own was 1.43 grams. The mass of the weighing boat now is 1.46 grams. That means 0.03 grams of solid is still left in here. Okay, and we want all of that solid in there, or we want to know exactly how much solid we've transferred into the beaker. So that's a really important point, and that is something that's called the weigh by difference. So how can we work out the mass of solid that we've transferred? So this is how you might record your results. So you'll have the mass of the weighing boat is 1.43 grams. The mass of the weighing boat and solid is 2.43 grams. The mass of the weighing boat, the second weighing, is 1.46. So to work out the mass of solid, you need to do 2.43 minus 1.46, which is 0.97 grams. Now you'll notice if we didn't do the second weighing, the mass that you would have transferred would be 1.00 grams. Okay, because you've not managed to weigh all of you've not managed to transfer all of that solid from the weighing bottle or weighing boat. Okay, so as I say, this is the weight by difference. Step 2, you're going to add some distilled or deionized water to the beaker. Approximately 100 centimeters cubed of water, and then you're going to stir. You're going to break up any large lumps of solid just to get it to be as fully dissolved as possible. Okay. Step 6, you're going to transfer the contents of the beaker and try to get all the solid into the volumetric flask, you're going to need the use of a filter funnel, and that is so you don't spill any. And again, it's really important, all the bits of solid in here we're wanting to get into the flask here. Step 7, we're going to add some more distilled water to our beaker, and we're going to wash. This is known as washing. So we're going to wash the rinsings of this back into the beaker, into the volumetric flask, and then we're going to use the distilled water bottle. We're going to wash this as well into here. So we're going to get the glass rod, and we're going to add some distilled water onto that, and we're going to wash all of that into there. And we're also going to wash the inside of the funnel. So we need to make sure that every last little bit of solid has gone in there. Okay, we probably do that several times, add several washings of this, making sure that we stay well below the mark. So there's the mark, we don't want to go above that. Step 8, we're going to add some distilled water, and we're going to make it up to the mark. Okay, we want to make sure that when we're adding the water, we do not go over the mark. So to do this, we need to get down, so we're looking at eye level at the mark, and the water will form a meniscus. So that's like a little sort of semicircle, and the bottom of that meniscus is what we need to be lining up with the mark. Really important, you're at eye level, and it's the bottom of the meniscus that's lined up with the mark. One of the techniques you might use to do this is you might use a dropping pipette to drop the last few drops of water into the volumetric flask. If you go over the mark, you've added too much water, you're going to have to start all over again, okay? Because you can't take some of the water out, because as soon as you've done that, you're going to be potentially taking out a little bit of the solute as well, so the concentration of this solution will not be known. So it's really important that you take it up to the mark, no more, no less. Step 9, this is one that people often forget when writing in an exam, for example, and that's to invert the flask several times until it's fully mixed. So you're going to need to up and down, not shake it, but you're going to put a bung in, and you're going to invert the flask a few times just to make sure that it's fully mixed. So in summary, these are the steps, and there are a few other things that we've added that are important too. Okay, so let's have a look at some exam questions. So I've picked some exam questions from the various different exam boards that demonstrate the sort of things that they seem to be asking, and there is a common theme. So the first exam question says, another student is required to make up 250 centimeters cubed of an aqueous solution that contains a known mass of MHCO3. The student is provided with a sample bottle containing the MHCO3. Describe the method, including apparatus and practical details that the student should use to prepare the solution. So this is a standard solution method. There's probably nothing really surprising. It's worth 6 marks. If you just go through and methodically lay out everything that we've already talked about today, you're going to get 6 marks. So let's have a look at the mark scheme. So there are 3 stages on the mark scheme. There's stage 1, which involves transferring a known mass of solid. So the first step is to weigh the sample bottle containing the solid, transfer to a beaker, and reweigh. This is the weigh by difference, and record the difference in mass. Okay, or it could be to place the beaker on a balance and tare, transfer the solid into a beaker and record the mass, or no mass provided, transfer that known mass into a beaker, wash the remaining solid. So it's essentially we're trying to make sure that all of the known mass of solid has gone in. Stage 2 is dissolving it in water, so it's adding distilled or deionized water, stirring or swirling until the solid has dissolved. Stage 3 is transfer, washing and agitation. So you're going to transfer it to a volumetric or graduated flask. That's underlined, that has to be written. With washings, make up to 250 centimeters cubed, and you're going to shake, invert or mix. Okay, let's have a look at another question. So a student wrote the following instructions to make a standard solution. Take a clean 250 centimeter cubed volumetric flask, use the balance provided and a clean dry container to weigh out the amount of solid required. Tip the solid into a clean dry 250 centimeter cube beaker and add about 100 centimeters cubed of distilled water. Use a stirring rod to help the solid dissolve, carefully breaking up any lumps of solid with the rod. When the solid has dissolved, pour the solution into the flask using a filter funnel. Add water to the flask until the level rises to the graduation mark. Suggest 3 further instructions that would improve the overall technique in this account. So we need to look at the technique, we need to identify things that they've not done, and then we need to say what it is that they could do. So, take a clean 250 centimeter cube volumetric flask. Seems good to me. Use the balance provided and a clean dry container to weigh out the amount of solid required. Tip the solid into a clean dry beaker. So, what we've got here is we've got the container to weigh out the amount of solid required, but we've not got this weight by difference. Okay, so what we need to do is they need to weigh out the amount of solid needed, then they're going to need to re-weigh and work out the mass of the solid that they've added. Okay, so there's that weight by difference thing that they've not said there. We've got the dry 250 centimeter cube beaker and we've added the distilled water. We've used the stirring rod to help the solid dissolve, which is good, carefully breaking up any lumps. When the solid is dissolved, pour the solution into the flask using a filter funnel. Okay, so that's all good so far, except we've not got washing. So we haven't got washing of the beaker. So that's where you would add some more distilled water to the beaker, pour that into the filter funnel, into the flask. We've not got washing of the filter funnel. And we've not got washing of the glass rod. So there are 3 washings there that they've not done that we could add as well. The other thing they said here about the graduation mark, they haven't mentioned use of the meniscus and at eye level with the mark and ensuring that you're at eye level, and they could have potentially said that you could use a teat pipette to add the final few drops just to ensure that it gets to 250 centimeters cubed. Let's have a look at the mark scheme. So we've got a method of weighing by difference or washing the solid into the beaker. We've got the washing the wet rod after use. We've got washing the beaker into the flask after transfer. We've got washing the filter funnel into the flask, use of a teat pipette to make it up to the mark, ensuring the bottom of the meniscus is on the graduation mark, and we've got mix, shake the final solution or invert the flask. Having just said earlier that everybody forgets that one, I did as well. Next question. This question is about the synthesis and reaction of butane 1,4-diol. Butane 1,4-diol can be oxidized to form butane dioic acid. The molecular formula of butane dioic acid is C4H6O4 and it's a solid at room temperature. Describe how you would make 250 centimeter cube solution of butane dioic acid with an accurately known concentration of approximately 0.0500 moles per decimeter cubed. Butane dioic acid is sufficiently soluble in water to achieve this concentration, and they've given us the molar mass, or the MR, of butane dioic acid. So we've been asked to calculate the mass needed, and we need to show how we would do the standard solution. So our first job is to calculate the mass of the butane dioic acid needed. And to do that, we're going to calculate the moles in the standard solution. So we're making up 250 centimeters cubed, and we know the concentration of this solution needs to be approximately 0.0500. So the moles of butane dioic acid that we need to add is 0.05 times 250 over 1,000. That equals 0.05 times 250 over 1,000 equals 0.0125 moles. Okay, Once we know the moles that we need to add, we can work out the mass that we would need to add. So mass is Mr. Moles. So the MR is 118. The moles is what we just calculated. So that's 118 times by our answer, which is 1.475 grams. So depending on the precision of our weighing scales, we could measure out 1.475 grams or 1.48 grams. I'd probably stick with 1.475 grams. Okay, and then we're just going to describe the standard solution procedure exactly as we would have done previously. So let's have a look at the mark scheme. So calculate the approximate mass of solute to be weighed out, which we calculated to be 1.475 grams. So that's your first mark. The second mark are details of how to weigh out the required mass. Do not award just weight by difference. So you can't just say weigh by difference, but essentially you've got to describe that. So that is the weighing of the bottle and then transferring that into the beaker and then weighing it again so that you can find out exactly what mass you've added. Because the solution needs to be approximately 0.05 moles per decimeter cubed. But it doesn't really matter as long as it's approximately 0.05. So you're aiming to add 1.475 grams, but you may not add 1.475 grams. You may add 1.471 grams or even more or less. The important thing is you know the mass that you've added. The third mark is for transferring the solute or the solid to the beaker and adding distilled water to dissolve. Okay, that's the third mark. Transfer of solute directly to a volumetric flask gets marking point 3 and 4, but must mention dissolving for marking point 3. It's better to do it into a beaker first. Then you're going to transfer it to a volumetric flask. Then you're going to add washings from the beaker. And then the final one, which is one that's often forgotten, is make it up to the mark and shake to mix. Okay. Final exam question that we're going to look at today. This is an awful lot to look at, but it's a simple 2-marker, really. So a student carries out an experiment to identify an unknown carbonate. The student weighs a sample of solid carbonate into a weighing bottle. The student tips the carbonate into a beaker and weighs the empty weighing bottle. The student prepares 250 centimeter cube solution of the carbonate. The student carries out a titration using 25.0 centimeters cubed of this solution, measured using a pipette with 0.1 mole per decimeter cubed hydrochloric acid in the burette. The sample of carbonate is dissolved in approximately 100 centimeter cubed of distilled water in a beaker and the solution transferred to a volumetric flask. The volume of the solution is made up to 250 centimeter cubed with distilled water. Another student suggests 2 possible sources of error. A small amount of solid remained in the weighing bottle. A small amount of solution remained in the beaker. State, so this is a 2-part question. Part 1, state whether the other students' statements are correct. And 2, how could the procedure be improved? So let's take a look at the first part. So a small amount of solid remained in the weighing bottle. Okay, so they've said that this is a possible source of error. Well, this statement is true to an extent, however, it's not a source of error. Okay, and the reason for that is because the student has reweighed the empty weighing bottle, so they've recorded the weight by difference, they've weighed the difference, so this is not a correct statement. Despite me having written the word true, which might be looking confusing, it's not correct because they have weighed by difference. Okay, the solid is remaining in the weighing bottle is not a source of error in this experiment. A small amount of solution remained in the beaker. Okay, so this is a correct statement. Okay, and the reason this is correct is because they didn't rinse. Okay, the student didn't wash the beaker and then add the washings to the 250 centimeter cubed solution of the carbonate. which leads us very neatly on to how could the procedure be improved. Well, the student needs to rinse out the beaker with distilled water and transfer that to the volumetric flask before they make it up to 250 centimeters cubed. Okay, let's have a look at the mark scheme. So, not correct about the solid remaining in the weighing bottle because they weighed by difference, and they are correct about the solution in the beaker. You don't need to say that because that's in brackets, by the way, it's just explaining it. And rinse out the beaker with distilled water and transfer it to the volumetric flask before making it up to 250 centimeters cubed. Okay, and that brings us to the end of this video. So we've looked at how to make a standard solution. I've been through some exam questions. The next video I'm going to do is focusing on the concentration calculations, and I'm planning to do another video about how to do a titration as well. I hope that was useful. Please let me know if there's anything else I could do, or if you would like any other videos to be looked at. Thank you again. Goodbye.